This is Unit 3, Household Electricity and Magnetism, the second part of the podcast 2, which is the cost of electricity. Now, first of all, I'm going to show you a scary looking diagram. And this scary looking diagram is a domestic wiring system in your home. Obviously, it doesn't look exactly like this, but what you really have are two main parts. You have what are called the ring main circuit. Now, the ring main circuit is just your plugs and your sockets, and all your sockets in your house will be connected into what's called a ring main, and every single socket, they're all connected in parallel, so you could use these in parallel. It means any one can be connected at any one time. You don't need all the rest on, of course. You can see, if you remember, I said in the last podcast that the wires that come into your house, or the cables that come into your house, are just live and neutral. Your third wire, the earth wire, is connected through each plug to a plate outside your house, so it doesn't come along the cables coming from the power station. So when the wires come into your house, the live and the neutral wire, the first thing you have in the live wire is a fuse. Now, you need a fuse in the live wire so that the current will blow immediately if too much current comes in from the live wire. And that needs to be fairly close to where it comes into the house. So you've got this big main fuse, and it's called the electricity board's fuse. And they will put it in to make sure that keeps the house safe. If too much current comes into the house, that fuse blows immediately. It means that if it was placed somewhere else, say it was placed in the neutral wire, and current's coming in the live wire, you could come along and touch that live wire. If the wires were bare, you'd get a huge shock. But because the live wire, the fuse is there, and if the fuse had blown over here in the neutral wire, you still would get a big shock from the live wire because the fuse, it wasn't in it and it didn't blow, if you touched it somewhere. But when the live wire's here and the fuse is in here, that means that the current if too much current enters the house, it blows immediately. And the same for all the other circuits. You always have your fuse and your switches in your live wire. Fuse always comes first before the switch, and the fuse comes first because you need to make sure that if too much current flows, broken the circuit immediately. If you had these two swapped round in this circuit, that would mean that if your switch came first, that you could have your switch closed over here, your fuse blowing, no current getting to the lamps, but if you touched here, you're in trouble. And that's what the problem is. So you need to make sure that your fuse comes first. Now, you'll have a lighting circuit. Lighting circuits don't use an awful lot of heat, so they would have a fairly small fuse, and that's for all the lights in the house, 5 amps altogether. And you would have fuses, individual fuses for different circuits in the house. You would have 30 amp fuse for all the sockets maybe that you use. You might have another 30 amp fuse not shown there, but you might have another one for your immersion heater. You might have another one for your cooker. If you've any other major things that need electricity, like say a sauna in your house, I'm not sure that that's likely, but you never know. If you had a sauna in your house, you would need a lot of electricity to heat the sauna, and so you might have a big fuse in there for that. Okay. The other thing that you have, if you look wherever your meter is, and your switches are, you'll see a meter. Now, in new houses, these are all outside. And the reason is because they belong to the electricity board, and they come along, they open the wee box and they read the meter. They don't have to need access into your house. In older houses, those are all inside the house, and you have to let the meter man in. So they come along, they read your meter, they send you a bill every 3 months. In older houses where they may not just always have access into the house, what they'll do is they read your meter sometimes, other times they just estimate your meter reading, and then at some stage the next time they read it, they will adjust what you owe them or they owe you if they've charged you too much. So this is called your domestic wiring system, and the most important thing you probably need to know about this is about how the meter operates, and we're just going to go through that now. So in your home, there's an electricity meter. Maybe it's outside your home. It records how much electricity you use. Now, it records an amount of energy. And we generally measure energy in joules. But this is the only time we don't measure energy in joules. We measure energy in kilowatt hours. Or if you look on your electricity bill, it will say units. So 1 kilowatt hour is the same as 1 unit. And the reason for this is A joule is a really, really tiny amount of electricity or energy. And if you counted up all the seconds that you used your electricity for, it would make the electricity board's job a nightmare trying to calculate how much you owe them. So they instead use a much, much bigger unit, and they call it a kilowatt hour. And we'll discuss how to get that in a minute. So here's, say, an example of your meter reading. If you look inside your box, you'll see numbers along the top. It said if the original reading was 6,895,600, how many units have been used here? So now you can see the number 6895, it's gone up to 702 from 600. So all you have to do is take away your 6895600, and you'll see there that when you take those away, you're really taking 600 from 702, and the answer is 102 units have been used, or kilowatt hours. I'll just write that, kilowatt hours. Okay? So what is a kilowatt hour, or what is a unit of electricity? Now, if you remember, I said it was an amount of energy. So a kilowatt hour is an amount of energy. That question's quite often asked. So kilowatt hour is an amount of energy. So our equation to calculate energy for electrical energy is power multiplied by time. However, even though when we calculate energy in joules, power is in watts and time is in seconds, for this purpose and this purpose only, for calculating cost of electricity, the power has to be changed into kilowatts and the time has to be measured in hours. So this gives you 1 unit of electricity, and 1 unit of electricity is equal to 1 kilowatt hour. Sometimes they ask you for a definition of a kilowatt hour. So a kilowatt hour is the amount of energy used when a 1 kilowatt appliance is used for an hour. One hour. Okay, so there's a wee question at the bottom, nice easy question. How many units of electricity is 17.6 kilowatt hours? And the answer, of course, is 17.6